All right, here we go. Today's lesson is on grouping in experiments. So, parents have worried that their kids spend too much time using a certain piece of technology that gives them access to addictive media content. Can you guess which technology? That's right, it's the radio. Yes, that's right, the radio. In fact, in this 1934 article from the New York Times, they observed that the radio seems to find parents more helpless than did the funnies, the automobile, and the movies. They include a quote from this lady, which you can read. It says, "Beyond dispute that many programs are objectionable because they convey false ideals or misleading sentimentalities, or because they murder the king's English or play too recklessly with the children's fears and horrors. A travesty indeed. But of course, it turns out that kids who grew up listening to radio end up being well-adjusted adults. However, that trajectory didn't stop those new adults from worrying about their children's access to another new invention, the TV. In a letter to the editor published in the New York Times, this time from 1950, a concerned reader reported that grades were dropping among students who had TVs at home. They went on to say that, quote, the statistics in themselves make it abundantly clear that the television represents a new problem for the world of education, extending far beyond the classroom itself. Such a medium that can command such a high portion of a child's waking hours is not merely a novel form of entertainment, it is a social force. And of course, it didn't stop here. The children who grew up on television then became adults who worried about their own children's exposure to arcades and video games. In 1982, you would have found in the New York Times this letter to the editor, where the author worried that video games were, quote, cultivating a generation of mindless, ill-tempered adolescents. And finally, today, the children who grew up on video games have become adults, now worried about their children's use of social media. You don't have to look far to find expressions of those worries. A quick Google search yields many results of articles voicing concerns about teenagers and smartphones, particularly about this impact of social media on mental health. Unlike prior tech hysteria waves, this one is associated with some real and potentially concerning data. 2008 was a pivotal year for social media. The iPhone App Store and early version of what is now the Google Play Store, called Android Market, both launched. That meant that constant access to social media through smartphones started becoming more widespread in the years that followed. So 2008 can be considered one of the last years before the social media boom. We can look at different youth mental health metrics between that year and more recently. Specifically, if we look at the percent of U.S. individuals aged 12 to 17 who had a major depressive episode in the past year, we see that just before the social media boom in 2008, the rate was 8.2%. By 2024, it was 15.4%. That's nearly double. In 2008, 10.4% of U.S. university students had an anxiety disorder. By 2019, that rate was 24.3%. That's more than double. In 2008, 217.2% per 100,000 people in the 12 to 18 age group had visited an emergency department for self-harm. By 2023, that rate was 518.5. That's a lot more than double. Now, smartphones and social media are one thing that could explain these trends. However, since 2008, U.S. teens have also faced a global financial crisis in the Great Recession, a pandemic from COVID-19, threats of climate catastrophe, and so much more. How do we know if social media is truly a cause of decline in mental health rather than any other potential factor? Trying to figure that out is our key question for today. Specifically, has social media caused declines in mental health? With that in mind, let's get into our guided notes. So I have 4 topics today, starting with completely randomized design. As we know, to answer a causal question, we need to do an experiment. Thankfully, because many people are also asking the same questions that we are, there's a growing body of experimental studies on social media and youth mental health. Today, we're going to look at one of those studies, which took place at Iowa State University. Iowa State, they recruited 230 student volunteers. They had 2 treatments, asking students to limit their social media to 30 minutes per day or asking them to use social media as normal. The student volunteers were randomly assigned to the normal use group or to the limited time group. Then the researchers waited 2 weeks to see what would happen. When they ran the experiment, it turns out in psychological evaluations, the limited time group had significantly lower anxiety, depression, loneliness, fear of missing out, and negative mood. Note that when we say significantly, we mean that the differences were so large that they were unlikely to happen by chance alone. More on that later in the course. This study is an example of what we call a completely randomized design. Experimental units are assigned to treatments completely at random with no pre-grouping. This is the simplest experimental design, like basically similar to a simple random sample in the realm of sampling. Right now, it's worth noting there are other ways to set up experiments, one of which is called a randomized block design. Imagine we had 8 subjects, 4 in the normal use group and 4 in the time limited group. The anxiety assessment scores are shown for both groups on the dot plot here. As we can see, after treatment, the limited time group, the group on the lower axis, tended to have a bit lower anxiety. But there was a lot of overlap. Many students from both groups had similar assessment scores, so it's hard to feel confident that the treatment had a substantial effect. Now, one thing that the Iowa State researchers pointed out in their paper was that female students tended to suffer from higher anxiety, so the researchers grouped the subjects, classifying them as not female or female. We can see that for both treatments, the non-female subjects tended to have lower anxiety in both treatment groups, and the female subjects tended to have higher anxiety levels. So by now comparing within those groups, the shifts in anxiety scores are much easier to see. In other words, by comparing within groups and controlling for some of the initial variation between female and non-female students, the treatment effect is easier to detect. Iowa State researchers used statistical models beyond what we learn here in AP Stats to compare the treatment effect within groups, the female, not female. How could we do the same thing but without such models? Well, we can use what's called a randomized block design, where experimental units are grouped in blocks based on an extraneous variable. Then the units are randomly assigned to the treatment compared within each block. This reduces extraneous variation, which allows for more precise comparisons of the response across treatments. And that makes the treatment effect easier to detect. So to see an example of this, let's explore how Iowa State researchers could have done a randomized block design using gender as the blocking variable. We begin by grouping the subjects into 2 blocks, female and not female. Once we have those blocks, within each block, we'd number the subjects 1 to n sub b, where n sub b is the number of students within each block. Staying within each block, we put the numbers onto slips of paper, put them in a hat, and mix well. This is how we're set up randomization here. All right, note, shuffling slips of paper in hats or containers is one randomization method among many others, including computerized random number generators. In each block, though, we draw half the numbers from the hat without replacement. The corresponding students are assigned to limit their social media time. The remaining will continue to use social media normally. Here's the key part. After 2 weeks, we compare evaluations of anxiety within each group. This is a key step for a block design that makes its comparisons more precise because, effectively, we're controlling for any initial variation in anxiety that may already exist at baseline between the gender groups. Finally, we combine or average those results to get an estimate of the overall treatment effect. Another type of experimental design in AP Stats we'll talk about is a matched pairs design. As we know, gender explains only a small part of the psychological factors that can vary a lot across individuals. So really, if we were to ask who's the ideal control group for this sample of students, it turns out the answer is themselves. This is exactly what a matched pairs design aims to do. A matched pairs design is a randomized block experiment in which either A, each block is composed of 2 similar experimental units, i.e. a matched pair, or B, the same experimental unit receives both treatments and the order of the treatments is randomized. To see an example of this, let's explore how Iowa State researchers could have used a matched pairs study. For each student, we would flip a coin. Heads indicates they reduce social media for the first 2 weeks, then use it normally the next 2 weeks. Tails indicates they use social media normally the first 2 weeks, then reduce it the next 2 weeks. Then for each individual, we'd find the difference between their anxiety evaluation scores after reducing social and after using it normal. In this way, we're essentially setting up a bunch of randomized blocks with each student becoming a block and being compared to themselves. Finally, we find the mean of the differences to combine the results across our matched pairs. All right, we're going to wrap up today looking at the generalizability of these sorts of experiments. In the Iowa State experiment, students in the 30 minutes per day group were expected to self-monitor their social media use. At the end of the experiment, they shared their phone data with the researchers. The researchers never enforced the 30-minute limit upon them. Remarkably, even though researchers did not enforce the restriction, there was still a significant treatment effect. Makes sense to wonder then, can this result truly be generalized to all students at the school? Remember that the 230 students in the experiment were volunteers. Therefore, a potential problem here is voluntary response bias. That is, compared to others, students willing to proactively volunteer to participate in a social media reduction study may be better at limiting their own social media use than others in the population who might not show interest in volunteering for such a study. In other words, these students might be different in their willingness to stick to treatment than other students at the school. So, when looking at the scope of conclusions from this study, we need to consider not just how the experiment was designed, but also how it recruited participants to be in the experiment in the first place. Since the treatment was randomly assigned, we can see a causal relationship. We know that among the students in the study, there was a causal effect from limiting social media. However, because the sample was volunteer-based rather than random, we can't necessarily generalize this result to the whole student population. We can only say that treatment would likely create an effect among students similar to those studied. In particular, for students not similar to those studies, maybe those who are more attached to their social media accounts and maybe less willing to stick to the guidance, the treatment wouldn't be as effective. This raises a question to make their study more generalizable. Why didn't Iowa State researchers gather a random sample of all students on campus? Well, it's because it'd be unethical and infeasible to force randomly chosen students to participate in the study. You can't force someone to sit for psychological evaluations, check in with researchers, share their phone data, and so on. For a study like this, you have to work with volunteers who give their consent to participate. So finally, let's tackle our discussion question for today. Because many psychological studies are done at universities, college students are often the subjects. If the same study we analyzed today were conducted with high school students, do you believe the treatment effect would be larger or smaller than the one found at Iowa State? Why? Take a moment to jot down your initial thoughts to this question, and we'll discuss further in class. That's it for today. See you next time.